Okay, so we've done a lot with deductive reasoning. Now we're going to do a couple with inductive. So we'll give you 4 different arguments. 2 of them are inductive, 2 of them are deductive. The big difference, inductive is more like pattern recognition. Inductive is opinion. It's really, you can't really prove it's 100% true. It's more opinion based. So, and deductive, you can always represent a deductive argument with a Venn diagram and prove it's valid, invalid, sound, unsound. So the inductive arguments, these opinions, these pattern based, they're either going to be weak or strong or totally false, but you cannot prove that they are true. So the more premises you have, the stronger they get. If you only have 1 or 2 premises, maybe weak. So here we go. First one. Premise number 1. Every person who visits the Everglades sees an American alligator. Premise number 2. Dolores and Franklin have never seen an American alligator. Therefore, we can conclude Dolores and Franklin have never visited the Everglades. Okay, so this has kind of a deductive feel. So, and it can be conditional. If you visit the Everglades, so this right here would be what we call the hypothesis, then you see an alligator, and this is the conclusion. So the conclusion, we can represent this with a Venn diagram. The conclusion is the bigger set. So you see alligator. And in that world there lives a subset of people who visit the Everglades. Okay, so premise number 1 kind of sets up your Venn diagram. Now 2 tells you where to put it. Premise 2, Dolores and Franklin have never seen an alligator, so they cannot live anywhere in this world, so they have to live out here. And I know exactly where to put them, so that is a valid argument. What's happening, they've never seen an alligator. They're talking about the conclusion. They are denying the conclusion. So it's valid. Now, do we think that it is sound or unsound? So maybe my first premise, every person who visits the Everglades sees an American alligator. I'm sure we can find people who have visited the Everglades who have not seen an alligator, so this is probably a pretty weak argument. Your first premise can't totally be true. So that might be weak, unsound. Okay, next one. Premise number 1. If I pay more for running shoes, they last longer. So if I pay more for running shoes, then they last longer. Premise number 2. If I pay more for my car, it requires fewer repairs. So the conclusion, quality comes with higher prices. Now this is an inductive argument. They're observing 2 scenarios, shoes and cars, and they're determining off those 2 observations that quality in general for any item comes with higher prices. So they're basing their conclusion off of 2 observations. It's inductive. It's probably weak because there's not many premises. But now look, we could turn this deductive pretty easy. Here's how you would turn it deductive. So if I pay more for running shoes, so that is my hypothesis, then they last longer. So that could be my conclusion. Now your premise number 2 we got to stay with my hypothesis and conclusion. So now premise number 2, then they jump to like cars. So premise number 1 introduces something that's happening with shoes. So premise number 2, we're going to stay with the shoes. So premise number 2, maybe my shoes have lasted 10 years. So then my conclusion would tie back into that first premise. So the first premise, if I pay more for shoes, they last longer. Premise number 2, I got a pair of shoes that lasted 10 years. So my conclusion, they must have been expensive shoes. And my second premise, they are affirming the hypothesis. No, they're affirming the conclusion. I've got some long-lasting shoes. So they're saying that's true. So they're affirming the conclusion, and that is invalid. But because they're looking at shoes, then they're looking at cars, and they're basing those two observations off a general statement, quality for anything comes with higher prices, that's inductive. They kind of base their thing off of pattern recognition. Okay, the third one, there is a city council meeting held every Thursday. Premise number 2, the mayor always attends city council meetings. So the conclusion, if you go on Thursday, I'm sure you'll find the mayor. Okay, this is also inductive. So they've kind of recognized the pattern. Every Thursday is a city council meeting. Mayor's always at the city council meeting. So they're saying if you go on Thursday, I'm sure you'll find the mayor. Okay, now it's pretty strong. We'll say it's strong-ish. Because there is a chance that the mayor will get sick, or maybe he'll have some emergency that he has to attend to and he can't go to a meeting. So it's not a guarantee if you go on Thursday that you're going to see the mayor. Because even if he misses one meeting in 10 years, it's not 100% chance. So, but it's pretty strong. Chances are really good. Okay, the last one. All fish have gills. Premise number 1. Premise number 2. Cutthroat trout are fish. So the deductive ones, you introduce a first premise, and then these are kind of all tying back into it. So if you are a fish, then you have gills. So this is the hypothesis. If you're a fish, the gills would be the conclusion. So cutthroat are fish. So they're referring to the hypothesis. They're affirming the hypothesis. Anytime you affirm the hypothesis, that is a valid argument. So this is going to be valid. So if we set up our Venn diagram, the conclusion's your big world. So there's a thing where anything that's got a gill lives in this world. And in that world there is a subset of a species of fish. And it says, premise number 2, cutthroat is a fish, so I live there. I know exactly where to put him. So it is valid. And he must have gills. And my first premise, I think that's true unless you find some kind of fish that does not have a gill. Some kind of weird species of fish. So for all fish, and you'd have to Google it, there may be a fish that does not have a gill. But if they do, then it is going to be a sound argument. Okay, now these ones. So your unit conversion. So if you're just straight up converting units, that's kind of the easier ones. If you have to use the unit conversion and then use it to find more information, and we're going to do that with proportions, that'll make it easy, but those are a little more challenging. So this first one, the New York subway, including stops, travels at an average rate of 24 kilometers per hour. If the Bronx is 20 miles along the subway from Coney Island, how many minutes is it going to take for the Warriors to get from the Bronx to Coney Island on the subway? So here we go. They're going to give us an initial rate. Your initial rate is going to be 24 kilometers per every just 1 hour. Okay, we're going to start with that initial rate. And then we're going from kilometers to miles, and then we're going from hours to minutes. So we've got to change both those units. I've got units of kilometers and hours, and I need to end up with miles and minutes. So it doesn't matter which one you tackle first. So let's go with miles. Okay, so I'm going to times this by 1. And since I've got the unit kilometers on top, I'm going to go kilometers on bottom and miles on top. And I'm going to use this conversion rate right here. So 1 mile is equal to 1.609 kilometers. Now if I times this, kilometers divides kilometers, times your top, so that's going to be 24 miles. And on the bottom, you're going to have 1.69 hours. Okay, now my calculator, I'm going to do 20. This is a decimal, so I'm going to get a decimal in return. So I'm going to do 24 divided by 1.69, hit enter. So it's like 14.201183 miles per hour. So it's not very fast, almost 15 miles an hour. Okay, so now let's see what we need. Okay, the Bronx, you gotta go 20 miles. So if right now you know that you're going at a rate of 14 miles an hour and you gotta travel 20, it's gonna, we can just estimate it's gonna take more than an hour. So it's gonna take a while. So, but they want it in minutes. So now let's convert that to minutes. So I'm gonna take this, my 14.201183 miles per hour, and I'm going to convert that to minutes. So I'm going to times that. I'm going to go hour on top and minutes on bottom. Okay, and we're going to use the rate 1 hour is equal to 60 minutes. So let's times that, times your tops. Hour divides hour. So you got 14.201183 miles in 60 minutes. Okay, now on my calculator, I'm going to divide that. I'm going to do 14 divided by 60. Okay, so that means I am traveling at, I'm just going to round to 4 decimals. It's almost a quarter mile a minute. So there's my rate right there. If I'm going 14 and change miles an hour, that is going to convert to 0.2367 miles a minute. Okay, so that's my rate. Now the question is, I need to travel 20 miles. So how long is that going to take me? How many minutes is it going to take me? And we estimate it's going to take more than an hour. So here we go. I'm going to use this rate, and I'm going to use a proportion. So proportions are going to make this piece of cake. You've got to set it up miles on top, minutes on bottom. So I need to copy that. Miles on top, minutes on bottom. And I need to go 20 miles, but the unknown is minutes. So we're going to use this proportion, and it's going to make it a piece of cake. Miles, minutes, miles, minutes. Now proportions, we're just going to cross multiply. So in front of here is just a 1. So if I do 20 times 1, I get 20. This is the unknown, so this is x. So if I do 0.2367 times x, I got 0.2367x. Now solve for x, so undo the times, divide this by 0.2367, divide that by 0.2367, so 20 divided by 0.236, we get x is equal to 84.5 minutes. And that's reasonable because we estimate it's going to take more than an hour. So that's a good answer. Alright. Our very own Mitty Stevens brought up something big right here. So right here, this rate, this 1.609 which converts the miles to kilometers. So I wrote it down, but then from here to here, I left out the O. I want 1.69, which is kind of close, but really not really. So if you use the rate 1.609, and if we don't round to the very end, you have x equals like 80.45 minutes instead of 84.5 minutes. And so that one mistake cost me like 4 minutes time. So it's a big deal. So even though that is like the hundredth place of a decimal, it adds up over time. So I really need to, I should have inserted an O right there, and then from there on out things got tweaked. So I mean, we were kind of close-ish, but not really too precise. So that's a big deal. Attention to detail is a way big deal. Okay, now let's do the next one. Suppose it takes 418 licks to get to the center of a Tootsie Pop. If you lick at a rate of 55 licks per minute, so I'm going to set that up. So this is me, there's my initial rate. 55 licks per minute. And your friend licks at a rate of 76 licks per minute. So my friend's gonna go 76 licks per minute. Okay. It takes 418 licks to get to the center. How many more seconds? And then we're in minutes. So I think we just got to change minutes to seconds. It's going to take for you to finish than your friend. Alright, so here we go. Let's start converting mine. So it takes me 55 licks per minute, and let's change that to seconds. So I'm going to times by a rate that puts minutes on top, seconds on bottom. So that's going to be 1 minute is equivalent to 60 seconds. So times your tops, minutes will undo minutes, and I've got 55 times 1 licks, and then on bottom that's really a 1, so I got 60 times 1, so that's 60 seconds. Okay, now I'm going to convert that to a decimal. 55 divided by 60, it's going to probably be nasty. 55 divided by, don't round until the very end. So I've got this number stored in my calculator as 0.916666666 blah 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 licks. So almost 1 lick per second. Okay, my friend, let's do the same thing. Let's change his time to seconds. So we're gonna go this times this, minute on top, seconds on bottom. 1 minute, 60 seconds. Minutes divides minutes. So we got 76 licks per 60 seconds. And if I do his 76 divided by 60, that is equal to 1.25 licks per second. So I'm almost doing 1 lick a second. He's doing 1.25 licks per second. Okay, now it's gonna take 418 licks to get to the center of the Tootsie Pop. So here we go. Now we're gonna use a proportion. I know that it's gonna require me 418 licks. The question is, what will the time be? So I've got my rate right here. That's 1 second. So if you set up a proportion, now cross multiply this way. This is the x. So I got 0.916 x equals 418. Divide by 0.916. Divide this by point. So on my calculator, I'm going to type in 418 divided by, and then I'm going to go up and grab that number. And it is going to take me 456 seconds. Okay, now my buddy, let's figure out how much it takes him. So I've got his rate right here of 1 1/4 licks per second. I'm going to set up a proportion. He needs to do 418. So let's put licks on top, seconds on bottom, and I don't know the seconds. Same thing, cross multiply. So his math is going to be 418 equals 1.26x. So divide that by 1.26. Divide that by 1.26. So I'm going to grab this number that I already have in the calculator, so I'm not rounding. 418 divided by oh, let's see, I did the wrong one. 418. And that is 330. It's going to take him 330 seconds. It's going to take me 456. So how much longer is it going to take me? So if I do 456 minus 330, it's going to take me 126 seconds longer, 2 minutes and change. Okay, now these next two, I think these are just straight up conversion, so no proportions. So these ones are a little bit easier. So Herbert owns an aquarium. It's 38 inches long, 14 inches wide, 16 inches high. How many gallons of water can he hold? So first let's find the volume. So the volume is just base times width times height. So we're going to take his 38, times it by the 14, times it by the 16, and that is all in inches. So 38 times 14 times 16, we've got 8,512 inches cubed.
How y'all doing? This is Brant Pratt. I'm telling you how math is very important, and it's awesome. Especially the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. There you go, bro.
Alright, so we got the volume calculated in inches cubed. We need to somehow figure out how many gallons that tank can hold. Now we're going to use this conversion right here, but here's the problem. I can hold 7.5 gallons in 1 cubic foot, but I'm in inches cubed, so I got to times this by inches cubed. We got to change it to feet cubed. So now here's the problem. 1 foot cubed, we got to calculate this on our own. 1 foot cubed equals how many inches cubed? So if we do a cube, it's 12 by 12 by 12 tall, 12 wide. And that's 1 foot, 1 foot, 1 foot. So we're going to go 12 by 12 by 12. So 12 cubed. That is going to be 1,728 inches. So here we go. 1 foot cubed equals 1,728. Okay, so I'm put this over 1. Now inches cubed kills out inches cubed times your tops. So I got 8,512 times 1. Now we're in foot cubed on the bottom, or on top. Times the bottoms, 1 times 1,728, 1,728. So now you got to divide this on your calculator. 8512 divided by 1728. And that's like 4.9259 blah 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 feet cubed. Okay, so now we're getting feet cubed. So now let's use this. So 1 cubic foot is equal to 7.48 gallons. So I'm going to put this over 1. And on bottom I need a foot cubed. And 1 foot cubed is 7.48 gallons. And so foot cubed kills foot cubed. So now we just got to multiply that. So I'm going to go 7.48 times that number I already got on my calculator. And we are approximately 36.8459 gallons. Okay, the average price of gas in Moscow is 33.28 Russian rubles per liter. Find the price in dollars per gallon. So here we go. I'm gonna go 33.82 rubles per 1 liter. So let's find the price in dollars per gallon. So doesn't matter, you either change rubles to dollars or gallons to liters. So I'm gonna change my liters to gallons. So here we go. I'm gonna times this. I need, if I got liters on bottom, I want liters on top, gallons on bottom, and I'm gonna use this. 1 gallon is 3.785 liters. So liters kills liters, and times your top is 33.82 times 3.75. So we got 128.0087 rubles per gallon. Okay, now we just need to change rubles to dollars. So I'm going to times this by something. If I got RUR on top, I'm going to put rubles on bottom and dollars on top. And now I'm going to use this. $1 equals 33.66 rubles. So rubles divides rubles times your tops. It's 128.0087. And it is in dollars. And on the bottom, 33.66 times 1 is just going to be 33.66 gallons. So now divide that 128 divided by 33. And you end up with like $3.8299 per gallon.